All right, guys, how's it going? Sorry for the delay, but I figured out now how to use Screencastify and be able to upload a video like this and be able to share it with you guys. You'll notice on your screen right now is a list of what we call the Trig identities. This identity sheet is also attached inside Classroom. You don't have to memorize these. You can print this out, refer to it. But what we're going to be doing for the next few days or weeks is going to be learning and working with what we call trigonometric identities. In our first lesson today, we're going to try to show you how I can make the left side of this equation equal the right side of it. So how does tangent x times cosec x equal secant x? And the way in which we're going to do it is we're going to simplify always the left side, never touch this side, the right side here of the equation. What we're going to do is we're going to rewrite these, what we're given, we're going to rewrite them in ways using the identities that are shown on the left-hand side of your screen. It's very important that you notice these methods, okay? The method you always want to try first before you get to any of these, which is down the road, is always try to replace terms using sine and cosine, okay? Rewrite whatever you're given, but rewrite it in a way that you now use sine and cosine. So that's what I'll do first. Instead of tangent x, and you guys can see how I attempt to write here. It's going to take me a few minutes, but sine x over cosine x. All right. So another way of saying tangent, we know, is sine over cosine, y over x. If you look at your identities over here, you'll see that, forget about the u, just think of that as an x or just any variable, but tan x, or tan u, is sine over cosine. What's left is cosecant. Well, how can we rewrite cosecant? How can we rewrite it in terms of sine or cosine? Well, we know that cosecant is the reciprocal of sine. So in other words, I could write it as 1 over the sine of x. All right, so I've rewritten in terms of sine and cosine. Now take a look at what you have here. We have to somehow make this equal secant. And there's not a lot of steps here. Once we rewrite, what do we notice we can do to simplify? We can cross these out, and what we're left with would be 1 over cosine, run out of room, 1 over the cosine of x, which is another way of saying secant. So we're done. This equals that. The work that you would need to show would just be exactly what I have there. Just show the process of you taking the left side of the equation and somehow getting whatever was asked of you on the right side. All right, let's try the next one here. Secant divided by cosecant, how does that equal tangent? Well, again, the first thing I'm going to want to look to do here is think, well, how can I replace secant and cosecant with sine and cosine? So I can do that by rewriting secant using what's called a reciprocal identity as 1 over cosine. Now, because I ran out of room here, rather than dividing by the reciprocal of cosecant, by dividing by like 1 over sine, I'm going to multiply. I'm going to multiply by the reciprocal of that. So if you didn't catch me there, what I said was I can replace cosecant, I'll just do it up here so it's out of the way, as 1 over sine. All right, so just picture this in the denominator down here. But I guess I could write it there, but without the room I have, let's just picture it's down there. And instead, what I'm going to do, instead of dividing by a fraction, let's just multiply by that fraction's reciprocal, which would be sine over 1. As soon as you get done rewriting in terms of sine and cosine, take a step back, take a look at what you have. And how can I simplify this? Well, this would just be sine over cosine, which we know is the equivalent to tangent. That equals that. All right. Next one. Okay, so let me point out again, which out of all these identities, we're taking it one step at a time. Right now, we're just kind of focusing on the reciprocal and the quotient identities. And we're really, as far as the methods going, we're just kind of sticking with the first two right now. All right. So I see secant times cotangent times sine squared x equals 1. All right. Regardless of what the exponent is, these identities still hold true. So like secant squared x, if I wanted to rewrite that, I could rewrite it as 1 over cosine squared x. All right. Cotangent squared. I'm going to rewrite that as well. Cotangent squared x would be cosine divided by sine. Now, if it was just cotangent x, it would be cosine divided by sine. But because it's cosine squared x, it's cosine squared divided by sine squared x. Now, there's no need to rewrite this one, right? Our goal right now is just to rewrite in terms of sine and cosine. But if you're given something already in sine or cosine, no need to rewrite. So we're just going to bring down sine squared x. And after you now have rewritten in terms of sine and cosine, take a step back and see what you can do to simplify. So we have a fraction times another fraction times sine squared x. Well, I can cancel out this numerator with this denominator, and I can cancel out this numerator with this denominator. So the cosines cancel, the sines cancel, and what we're left with is just 1, right? Everything cancels out here. Everything simplifies. And that's what we needed to verify. We needed to prove that the left side could somehow equal that right side. All right, last problem. Again, cosine squared times sine squared x times sine x is going to equal sine cubed x. So all we have to do is rewrite what we're given in terms of sine and cosine and see what we have. I have cosine squared, I have tangent squared, and sine squared. So I'm going to get rid of this one right now. I'm going to replace tangent. I'm going to rewrite it with sine squared x over cosine squared x. All right. Now, the other two parts, the cosine squared, no sense of nothing to do there at this point. Just bring that down. And if you'd like, you can put it over 1 if that helps you see it a little better. And the sine x I could put over here. That can come down. And I can also put that over 1. All right. So again, we have this in mind that this somehow has to equal sine cubed x. Well, again, we're going to simplify. Sine squared times sine, think of it as x squared times x, right? You would just add the exponents, and this would equal sine cubed x. All right. So guys, that's it. That's it for our first lesson. Hopefully now you have an understanding and you guys can watch this as much as you need. You can pause it, take notes, but I would, again, make sure I print out a copy of this or at least refer to the identities as I go about it. After you guys watch the video and take notes, I'm going to post a couple practice problems. Let you guys try the practice problems. They'll be set up just like these. And then hopefully, I'll post an answer key. You can see how you did, and we can talk about that later. But hopefully this worked out well. This is how we're going to kind of continue to keep in touch and learn new lessons. I appreciate everything so far. You guys have been great as far as submitting assignments and stuff. So keep taking that positive approach as we move forward. All right. Miss seeing you guys in class, but we're going to make the best out of this situation. All right. Thanks. Thanks again.